Let us discuss one important problem from ray optics, only meant for JEE Main and Advanced only, not for NEET. Find the condition of no emergence of light from a glass prism for whatever be the angle of incidence I. So I hope you are familiar with the basic laws of refraction. That is, if this is a boundary separating two different medium, let's say this medium has a refractive index mu2, this has a refractive index mu1, and here is a normal to the surface. If a ray of light is incident from this medium to this medium at here, and if this is rarer, this is denser, from the original direction it bends towards the normal, and angle of incidence is I, and this angle of incidence is called R, and sine of this angle by sine of this angle is equal to mu2 over mu1. This is what you know. And more the contrast in the refractive index, more will be the bending of light. That is the physical meaning of mu. Now, if you look at this diagram, this A, B, C is a glass prism. This is the base of the prism. So this angle A is called the angle of the prism and also called the refracting angle of the prism. This PQ is an incident ray coming from a medium of refractive index mu1 and trying to enter this glass prism at point Q, and the refractive index of the glass prism is mu2, and the other side of it is also refractive index mu1. I will consider mu1, this mu1 as a rarer medium and mu2 as a denser medium, the glass. So this incident ray is hitting the surface AB of the prism at Q. So at Q, this is the normal. So this is your angle of incidence. And this ray, incident ray PQ, was supposed to travel in this direction, but going from rarer to denser, it bends towards the normal. From the original direction, it bends towards the normal. So this angle is your angle of refraction. Let it be R1. Again, at point R, it is trying to be refracted, trying to go from denser medium to rarer medium. Now, as you know, if this angle of incidence is less than the critical angle, then only this ray QR will come to this side. If this R2 is equal to the critical angle, then QR at point R will travel along RC, means making this angle as 90. Right. Now, and you also know about total internal reflection. If R2 is greater than the critical angle, then instead of coming to this side, it will be reflected in the same medium, making this angle is equal to this angle. So now it is simple. So here, if you apply the Snell's law, that is the second law of refraction, sine I over sine R1 will be mu2 over mu1. Now, if mu1 is vacuum or air, then I can take mu1 as 1, that is for air or vacuum. So I should rewrite this equation as sine I over sine R1 is equal to mu2, because if I take this as a rarer medium, that is air 1, so mu2 over 1 is mu2. Let mu2, we represent it as mu, right? Now the question is, what will be the maximum value of angle of incidence on this side? If this is the ray, this is the angle of incidence. If this is the ray, then the angle of incidence is more. If this is the ray, then the angle of incidence still more. So this angle of incidence I can reach up to a maximum value 90. So in that case, what will be R1? If in the rarer medium angle is 90, then in the denser medium, this angle will be called the critical angle. So the maximum value of I this angle of incidence is 90 degree on this side. If it is 90 degree, then R1 will be equal to critical angle, which I represent it as C, where C is called the critical angle. Now, again at this point, this refracted ray not to go to this side, that is to be, it is to be totally internally reflected, this must be greater than C. So now there is something interesting. So this QR not to come to this side, R2 is greater than C. R2 is greater than C. And for maximum value of I, that is 90, R1 is equal to C. So R1 plus R2. So R1 plus R2 will be greater than 2C. This is greater than C, and R1 is equal to C. So R1 plus R2 will be greater than 2C. This is to be understood. So if R2 is equal to C at R, if this is equal to C, which I just explained, then this QR will travel like this, grazing the surface, means making angle 90 here. If R2 is greater than C, then it will be totally internally reflected. So if R2 is C at R, refracted ray will travel along RC. Now if R2 is greater than C, it will totally internally reflected. Now, so we have two things. R1 is equal to C and is R2 is greater than C. And we know for a prism, this angle of angle of the prism, or also called the refracting angle, is always equal to R1 plus R2. That you must have derived in your college or school days. So I'll put that condition here. Angle A is always equal to R1 plus R2. And I just explained how R1 plus R2 is greater than 2C. So angle A is greater than 2C. Now if you write it, so your 2C will be less than A. So your 2C will be less than the angle of the prism. So 2 is multiplied, take the right hand side, it is divided. So C is less than A by 2. And we also know 1 by sine C is equal to mu. How? I can explain it here. Suppose this is a denser medium, suppose this is glass. On this side is AR, and this is a normal. Here is the angle of a ray traveling from glass to air. If this is equal to the critical angle, then it travels like this. It is 90 degree. Now, students normally make mistakes here. Its refractive index is mu1, its refractive index is mu2. Here, if you apply Snell's law, how you should apply sine C over sine 90 will be equal to the medium to which it is going, refractive index of that divided by refractive index of the medium from which it is coming from. Since I have taken this as AR, so this is equal to 1, this is equal to mu2. Now sine 90 is 1, so sine C is equal to 1 by mu2. I have considered mu2 as mu, so sine C is equal to 1 by mu, or you can say, so this is what I have written here. 1 by sine C is mu. Here you have to remember, how you have to remember like this. We think of critical angle. When you think of critical angle and the refractive index, this C, this angle C, the critical angle, is in the denser medium, and this is the refractive index of the same denser medium with respect to the other medium. That is what you have to remember. I have to explain it once more here. When you write 1 by sine C is equal to mu, mu of which medium and C is in which medium? C has to be in the denser medium in that case, and mu is the refractive of that denser medium with respect to the other medium. That is what you have to understand. So now since C is less than A by 2, I take sine function here and sine function here. So sine C is less than sine A by 2. Now I take the reciprocal. So 1 by sine C will be greater than 1 by sine A by 2. Now how? suppose sin C is equal to, suppose this is a number, this is also a number. Some number is less than some number, let's say 2 is less than 5. Then if you take the reciprocal, then 1 by 2 will be greater than 1 by 5. 1 by 2 is 0.5 and that is greater than 1 by 5. So when you take the reciprocal, the inequality sign changes. And 1 by sin C, I just explained how this is mu. So mu is greater than 1 by sine A by 2. 1 by sine theta is cosecant theta, so it will be cosecant A by 2. So this is the condition for no emergence of light, where mu is the refractive index of the prism, A is the angle of the prism, so mu should be greater than cosecant A by 2. This is what you have to remember, this part, and also this part. 2 times the critical angle should be less than the angle of the prism. These two conditions, this condition, and this condition you have to remember. So I hope it is clear to you. If you have further questions, you can write me. So thank you.